For our next problem, some example number 3, uh, the statement here says that let's going to resolve f sub 1 and f sub 2 into components along the u and v axis and determine the magnitudes of these components. Okay, so the figure of the said problem is here. So we have first force, or F sub 1, which is equal to 250 Newton, and then our second force is 150 Newton. And then the angle between the U-axis and the first force is 30 degrees. The same angle with um, the angle between the second force and then the U-axis. And then we have below the U-axis, we have here the angle 105 degrees. Now, but in order to solve this kind of problem and and in force vectors, first let us going to draw its free body diagram. So since we have two given forces here, and then we are required to solve for the components of the said forces f sub 1 and f sub 2, then let us going first to solve for the components required for the first force for the 250 Newton. Okay, so now let us draw the free body diagram for the first force, which is 250 Newton. So here it is. So this is our V component, V axis, and here is our U axis. So we are going to solve for the V component of our first force and then the U component of F sub 1. So as you can observe, here is the 30 degrees or theta. So and then the 105 degrees is here. So we know that this arrow, this is our resultant vector, which is 250 Newton. This is our F sub 1. Now let us going to find the two components, which is the V component and the U component. So in order for these two components to be solved, of course, we are going uh, to get first the half portion of the parallelogram, because this is already in a form of parallelogram, and so that we can apply the parallelogram law. And then we know that half of it is a triangle, and we can apply the sine law or even the cosine law. And based on our figure, we know that the given we have three given angles, and by inspection we can easily solve this kind of problem, or we can easily solve the required variables, which is the f sub 1 v and then the f sub 1 u, using sine law. Okay, so using sine law, first let us going to find the u component of the f sub 1. So 250 Newton divided by the sine of its opposite angle, which is 105 degrees, equal to the f sub 1u, or the u component of the f sub 1, divided by sine of its opposite angle, which is 45 degrees. Okay, so applying a cross multiplication, we can have we could simplify that f sub 1, so 250 times sine of 45 degrees, and then f sub 1u times sine 105 degrees. So this is already simplified one. So using your calculator, we can have f sub 1u will be equal to 183.01 Newton. So that is just for the u component. Next is to solve for the V components. So again, let us still using the sine law, because it is the most applicable or easiest way to solve for the variable that we are required to solve. Okay, here is again sine law, 250 Newton divided by sine of its opposite angle, which is 105 degrees, equal to f sub 1 v divided by the sine of its opposite angle, which is 30 degrees. And then again, the same method from the previous one, using a little bit algebra or trigonometric simplification using cross multiplication. F sub 1 v component will be equal to 250 times sine 30 divided by sine of 150 degrees. So using your calculator, our vertical component, our v component for the f sub 1 will be equal to 129.41 Newton. Okay, so this is already our answer for the u and v component only for the first force. Now, in the second part of our solution, let us going to solve for the u and v component for the second force 150 Newton, which this is already our resultant vector. Let us find its components, u and v components. So first, let us going to draw its free body diagram, and we have here. Okay, so this is already at parallelogram law. So applying its, so here is the v component, and this is the u component. So okay, in this free body diagram, so let us going to identify uh, the angles and where is the v and u component and their our resultant vector. So we know that this is already our second resultant vector for the f sub 2. This is already our resultant vector. Okay, so the 30 degrees here is taken from based on the figure. So here, so this is the same as this one. This is just a free body diagram. And then where did this 75 degrees came from? Okay, so let us first let us go back to the given figure. We have given here a 105 degrees, and we know that a straight line is equal to 180 degrees. Thus, 180 degrees minus 105 degrees, I think it is equal to 75 degrees. Okay, so this is the angle here is already 75 degrees. Now, and this axis, we know that this is also a straight line, and we have a given here 30 degrees. This is already 75 degrees. And then what will be the angle here? So the same as here. Okay, so let us compute. We know this is already equal to 100. The total angle will be equal to 180 degrees. Okay, 180 degrees minus 30 minus 75. It is equal to 75. So the angle also here is also 75 degrees. So again, how to solve for the angle here? So based on the theorem for the straight line, that a straight line is equal to 180 degrees. So 105 plus 75 degrees is 180 degrees. Okay, so to find the angle here, this is just the same concept here, that the v or the v axis is already, it is a straight line which is equal to 180 degrees. Thus 30 plus 75 here is already equal to 180 degrees. So this is where this angle taken. So they are just based on the given figure. So just a little bit simplification. Just recall your what do you call this, your knowledge on the plane trigonometry. So next, so we already have a parallelogram, and then we can apply the cosine and sine law by cutting the half portion of the parallelogram. So we have a triangle here. So this is already our v component for the f sub 2. This is our u component for the f sub 2. So this is, so the angle, so So this is our V component. So the 75 okay, so this is a 30 degrees. Okay, as you can observe, this is a 30. And this one is, we know that this is already equal to the our f sub 2 V component. So there it is. And then the angle here is just equal to the angle here. So this is 75 degrees. And of course, the angle here is just equal to the angle here, which is also equal to 75 degrees. And if you're going to check, we know that a triangle is the total sum of its angles is equal also to 180 degrees. So 75 plus 75 plus 30 is equal to 180 degrees. Now, what will be the most suitable law for this kind of situation, or we have a given variables? So based on by inspection, we could say that we can use anew the sine law, because the all the angles all the opposite angles are given already. So again, let us use sine law. By using sine law, 150 Newton divided by its opposite angle, which is sine 75 degrees, equals f sub 2u. So here it is, divided by sine of its opposite angle, which is 75 degrees. Okay, by using a cross multiplication, we have 150 divided by sine 75, and then f sub 2u times sine um, 75 degrees, and then let us divide both sides by sine 75 degrees. So we can cancel out the sines of 75 degrees here, and then this is the remaining. So this is our equation. So using your calculator, we can say that our f sub 2u, or the u component of our for this force, is equal to 150 Newton. And the next is to solve for the v component for the second force, the v component of f sub 2. So the same concept, same method, 150 divided by sine 75 equals f sub 2v divided by sine of 30. So anyway, you can also use the other one, or we can say um, 150 Newton. Let us use the f sub 2 u, 150 Newton divided by sine a. They are just the same. They are just the same value. So anyway, so let us proceed. So uh, using again cross multiplication, so we can have a derived or simplified form like this. So this is our equation to solve for the f sub 2, the big component of our f sub 2. So again, using your calculator, we can say that our f sub 2 v component, or the v component of f sub 2, is equal to 77.65 Newton. So that is how to solve for the problem for sample number